Hey everybody, this is a quick tutorial on how to process data and create graphs on Google Spreadsheets. Everybody should be using Google Spreadsheets to process and graph their data. Nobody should be plugging numbers 20 times into their calculator to put out values because that's not the correct way to do things. Data processing and graphing should be the shortest thing in terms of time to do on your lab. All of you spending, 4 hours or 2 hours doing the lab and making graphs, you're doing it wrong. So here's how to do it very quickly. This is my falling for you data. I collected it from my own ticker tape. So over here I have the tick mark. So this is the dot number on the ticker tape timer away from 0, and this is the position that it was away from 0 in centimeters. Now I know that this tick doesn't actually represent time. It represents how many 60ths of a second it was from the start. So in order to get the time, what I need to do is divide each one of these ticks by 60, because this is 9/60ths of a second. So to get the time, I need to divide by 60 to properly scale that. So I could do this in my calculator one by one, or I could do it very quickly in Google Sheets once and then have it iterate over the entire collection of my data. And so I press equals, and that sets up formula mode in that particular cell. And then what I do is I need to divide 9 divided by 60, and I just press enter, and it automatically does the calculation for me. And if I take this little square here, notice how the cursor changes over that square to a crosshair, and I click and drag it down. It iterates and calculates all of them for me. Okay, I can adjust how many decimal places I want to have, whether less or more, by clicking these buttons. Doing the position, as we discussed earlier in class, we need the if we're doing an average velocity for position 10, I need to take the position before that, or rather after the dot, minus the position before that. So entering formula mode for the cell again, I'm going to take 15.2, the position after that dot, subtracting the position before that dot, and multiplying that by 30. We discussed how to do this in class. If you're unclear of why I'm multiplying this quantity by 30, just come see me or look at your notes. So then I get 162. I do the same thing. I click that little square towards the bottom, and I get these values. Notice how this last value is really weird. I don't need that value because it's actually processing a position after 23, which I don't have, and so it's giving me a weird number. So I really only need this amount of data. Creating a graph is really fast. In order to create a graph, I want to create a graph from this time. I don't want to select this time because it has no corresponding average velocity data. And I want to drag this down, and then I want to select my Y data, which is right over here, which is, I can't really just do this because I'm selecting too much data. So I select the data I need in time, hold Control down on my keyboard. If you're using an Apple, I think it's Command. And then I drag that down and select the second column. Then I go up to this button here that says Insert Chart. I click, and then I bring up chart types, and I select only scatter plot. This is the only graph you will ever need to make in my class, scatter plot. Do not plot in line. Do not do this, please. That is not what I want. Do not do this. That's not what I want. Do not do a bar graph, please. No, scatter only. Okay, so insert that. And you notice you get a trend line. This last dot is a legend. That doesn't matter. You could delete that. You can clear that legend, and that's not there anymore. Here's my graph. I can add a trend line just by clicking on the actual dot, clicking there, and clicking linear. Okay. If you want the formula, you go to Advanced Edit. You scroll down. You go to Label, and you go to Use Equation, and you go Update. Oh, I removed the legend, so let me actually put that back. So this gives me the equation for the line, and notice how it's 936. My actual value, meaning the real life accepted value, is 980 or 981 centimeters per second squared. This is a little low, but you can also tell that it might be a little bit low because it's not exactly intersecting through 0. It's close, but it's not perfect. So let's get the actual slope using another formula or function that's available to you in Google Sheets. So in order to do that, now I'm going to put my graph aside. I'm going to leave it there, and I can label it later on. I'm going to click a blank cell. I'm going to say this is equal to lin s, so meaning a linear estimate. And I'm going to open parentheses. I'm going to select my y values first, comma. I'm going to select my x values next, comma. I'm going to type in false. This basically says that this is the data on the y I want, this is the x data I want, and false meaning it has a y-intercept of 0. So do not give me a y-intercept. I'm telling you that it's 0. So enter, and then it gives me a value of 977.38. If you calculate the percent error on that, that ends up being less than 1% error, which is really, really, really good. I can even show you another function here, which you could do. That would be the absolute value of this value minus 980, which is my actual value, divided by 980, and this all multiplied by 100 to get me the percent value. So times 100, and I get 0.26, so about 1/4% error, which is really, really, really good. And you don't see that often. So please, please, please use Google Sheets. It takes you about, maybe this was 6 minutes worth of work, and you get nice graphs that you can look at, and doesn't take very long to make at all. And you get your actual numbers and errors, which is very easy to do. This makes your life easier. Use it. Thanks, guys.